In this segment, we will start with the first step in the research process, which is stating the problem. As discussed before, stating the problem is the first step in the research process. This includes determining the issue and developing a hypothesis. First, I'll go over the kinds of questions we can ask, and then we'll talk about how to come up with the questions, and lastly, how to state our hypotheses. In the overview, there are different reasons for doing research. These reasons often determine the kinds of questions we need to ask. For example, if we are interested in describing a phenomenon, we may want to ask questions about the definition and distinction between that idea and other similar things. We may also want to know how many people in a given population have a certain characteristic. For example, what is the percentage of people in the U.S. workforce with a master's degree or higher? If we want to predict outcomes, we will want to know about relationships between variables. If we know the value of one thing, we can predict or guess the level of the other if the two variables are significantly correlated. If we know the direction of this relationship, that is, whether they are positively or negatively related, it's obviously even better for prediction. Just because we can predict one thing from another, however, does not mean that the two things are causally linked. It just means that the two factors work together for any number of reasons. So, example questions we may have here: is education level related to job performance? If so, is higher education related to better job performance? If we want to make changes, we will need to know about the reasons and causes behind relationships. Which thing is influencing the other? Or is there some third variable that's influencing both? So we will ask questions about the causality. Does getting a degree make someone a better employee? Does being a better employee make you more likely to get a master's degree? These have a special MBA program that they pay for high achievers. We can also ask, does being more intelligent make someone a better employee and more likely to get a degree? In this case, we have a third variable explaining both of the latter two variables. We need to turn questions into hypothesis statements in order to test them. Let's look at a couple examples. We may have a question about why employees are continually quitting. A hypothesis makes a statement about what we think is going on, and it's this statement that we test. For example, we may think changes to the company benefits are to blame. We can turn this into a hypothesis by saying, employees are quitting because of the changes to the company benefits. We can also have multiple hypotheses about any problem. In this case, we might have another hypothesis that says employees are quitting because a new factory opened in town and is offering higher pay. Another possible issue we'd be interested in is happiness of employees. Why are flight attendants at Airline 1 happier than flight attendants at Airline 2? Again, we search for reasons why and create a hypothesis statement. Perhaps we think support from management is a factor. We could say the level of perceived organizational support from management is different between Airline 1 and Airline 2. However, this statement doesn't directly assess whether it's related to employee happiness. So we may have a follow-up hypothesis. The level of perceived organizational support is related to daily employee happiness. As we discussed earlier, we can predict a relationship with or without having a prediction about the direction of that relationship. For a correlational hypothesis with a predicted direction, it will look similar to this. Evenly divided workload is associated with a higher group satisfaction. Key phrases you would find in a directional correlational hypothesis are things such as is positively correlated, is negatively correlated, is positively or negatively related to, and is related or associated with a higher or lower level of the other variable. We often diagram such correlational relationships with a double arrow, indicating that the relationship may go in both directions. A hypothesis with the same variables, but without a direction predicted, will look something like this. Evenly divided workload is related to satisfaction. Key phrases in non-directional correlational hypotheses would be things like is related to, is associated with. We can also predict a causal relationship, with or without having a prediction about the direction of that relationship. So a directional causal hypothesis would be similar to this. Balancing the workload of team members will increase team member satisfaction. In this case, we have a key phrase of will increase. By saying will increase indicates that the first variable of a balanced workload is having a causal impact on the latter variable of member satisfaction. We often diagram causal relationships with a straight line with an arrow on one end, indicating the direction of the causality. A non-directional causal hypothesis will look like this. Balancing the workload of team members will change member satisfaction. In this case, will change indicates the causal relationship, but we don't know whether the dependent variable, satisfaction, will go up or down with changes in the balance of workload. So coming up with ideas. We can come at problems from a couple different ways. We can base our experiences or things we've seen, or by using a theory. We call these approaches inductive and deductive approaches. A theory explains the relationship among phenomena and gives us a framework within which to conduct our research. So for deductive reasoning, we go from a theory and we deduce from an abstract explanation. With induction, we come at the problem from experiences and we make generalizations about observed phenomena. We begin to see patterns in the experiences that we've had. So let's just go through a couple examples. Inductive reasoning. Say we have these observations. We have Mike, who keeps working on the hardest Sudoku puzzles even when he keeps getting the numbers wrong. He also, when doing a pull-up for a physical fitness test, will keep trying even when noticeably shaking from the muscle fatigue. He decides to try a new diet, and even though he finds the food disgusting, he sticks with it through the month he agreed to. He comes home after a difficult day at work and patiently tries various incentives when his kids refuse to clean up. With Joe, however, we observe other behaviors. He messes up twice trying to do a puzzle, and then he quits. He gives up on the pull-up test as soon as he feels a little tired. He decides to try the same new diet with Mike and gives up after the first day of the bland food. He comes home after a difficult day of work and yells at his kids when they refuse to do their homework. Then he feels bad about it. What can we conclude from these observations? Well, a couple things we could conclude. Some people have more willpower or self-control than others. We could also conclude that if people are good at controlling themselves in one situation, they tend to be better at controlling themselves in other situations. So that would be induction. Deduction, however, uses theory. A theory is a set of principles that explains and predicts relationships between and among variables in a particular domain. So, for example, you've probably heard of social learning theory, where we learn from watching others. I'm also going to talk now a little bit about the strength model of self-control. A good theory is general. It summarizes many outcomes. It's parsimonious, which means simple. There aren't a lot of variables and relationships within it. It provides ideas for future research. And it is falsifiable in that it can be shown to be incorrect. The strength model of self-control, laid out by Baumeister, Bose, and Tice in 2007, indicates that self-control is like a muscle. When we use it, it gets tired for any subsequent self-control tasks. But over time, as we use it, it gets stronger. Our ability to self-regulate is better. So what hypotheses can we create from this? Let's look at some possible self-control activities. Things like meditating, deep breathing, keeping to a diet, not getting angry, or not acting upon your anger when you are angry, not laughing when you know you shouldn't. Parents might experience that often when their kids do silly things, but things that we should not be reinforcing them to do. So let's take a couple of these activities. This is one I had not mentioned there, but emotional control during work. Perhaps not showing that anger when you are angry. If your job includes this as a requirement, we call this emotional labor. It is the effort that's given or the labor that's put into keeping your emotions under control. If we spend a day doing a lot of emotional labor, we may find, based on the strength model of self-control, that we have less dietary restraint. So we go home in the evening and we aren't able to keep that diet. Another possible hypothesis related to work would be that the time we spend meditating may increase our ability to regulate emotions at work. For people who have jobs that contain a lot of emotional labor, customer service representatives, salespeople, anyone who works with clients need to keep their emotions under control. Likewise, police officers or judges may need to keep a more flat or negative emotional display when they may want to laugh at a situation. So what makes a good hypothesis? First of all, it is in statement form. A hypothesis is not a question. It is simple. It is very specific. It uses testable or measurable variables. If it's causal, it's often in the form of an if-then statement. If it's correlational, it's often described as a relationship or an association. At some point, we need to turn our hypotheses into statements that include the measure we're using for our variables. In this case, we may be interested in emotional labor, but we may be more specific in how we test that by saying that we're looking at showing happiness when the person is angry as rated by that person. And that our dietary restraint may be specific to eating birthday cake that is in the employee lounge, or in this case, not eating birthday cake. So those who are showing happiness when they're angry are doing emotional labor. The more emotional labor, the more likely we are to eat the birthday cake. So this is a good statement because both are measurable variables, and it states a measurable relationship between the variables. This is also a causal directional hypothesis. We are predicting which direction, and we are saying it is because of the activity in the first variable that is changing the outcome in the second. So let's take a look at some bad hypotheses. Can providing breakfast for employees get them to work on time? Think for a moment about why this is a bad hypothesis. The primary problem here is that it isn't a statement. It's a question. We need it to be in statement form. When we test the hypothesis, we are going to ask whether there is support for this statement or not. Another hypothesis could say, the Excel training program is the best. This has a couple problems with it. Best is a value judgment. Often, programs are better on some things and worse on others. Often programs have improved performance on some things and decreased performance on others. It also does not have a comparison. What is this compared to? What would it be better than? Or in what ways would employees be better trained in this program than in another? Race causes students to have lower performance. Race causes students to not choose engineering as a profession. Race may be associated with certain outcomes, but there are underlying reasons why. This is the third variable issue. We can look to these third variables for causality, but we cannot say that the median income level, we could say the median income level of neighborhoods, and we could say the median income level of the neighborhood in which one grows up leads to being less likely to become an engineer. We also cannot test a causal hypothesis about a variable we cannot manipulate. I will say that there have been several researchers and reporters that have gotten very creative about perception research. And I certainly don't want to squash any high goals, but we would need to be cognizant of what we are proposing when we create a hypothesis about a variable that is not easily or ethically manipulated. So as you go through this week, if you have some ideas about hypotheses at work, use the discussion board for Module 2.